Alrighty. Good afternoon, everybody. I assume you're probably not watching this in the afternoon, so good morning or good evening. I need to stop saying the same thing at the beginning of every video. I'm sorry. Hello, and welcome to another installment of Calculus Did You Know Style. So in this video, we're going to be talking about the product and the quotient rule. So what the product rule is, my air bomb's upgraded, is that I have essentially two functions multiplying with each other. So like if I had f of x equals sine cosine, right? These are the types of things that I am talking about, where we won't be able to take the power rule, and there's not constants, there's nothing else that I can do, so I have to use the product rule in this situation. So the way that this works, and really I do it the opposite way in my head, but it is the first function times the derivative of the second, right? So there's the first and the second. So the first function times the derivative of the second. Let's go ahead and just walk through this very slow next to our rule. So the first function would be sine of x, and the derivative of the second would be negative sine of x, because I have kind of my, where is my favorites? Favorites, come back, I need you. So first, second, sometimes I'll call this like uv. So this is uv prime plus u prime v, or vice versa, right? It really doesn't matter the order that you do this in, because addition is, commutative, right? I can move around the same community, but still in the same, yeah, I think it's commutative. Doesn't matter, you don't need to know that. Okay, so this was u v prime. Now I need to do plus u prime, which is the derivative of sine, which is cosine, and then v, which is still cosine. So there would be my derivative. I don't need to rewrite this or anything. I can leave it just like that and be happy. That's all I really need to do. I can simplify if this I want. So cosine squared minus sine squared, which is actually cosine of 2x, but you won't need to necessarily know that identity right now. Okay, so that's what the product rule does. The product rule allows me to take two things that are multiplied together and take the derivative of them kind of separately and multiply them together. All right, now the quotient rule is the division. So in the last lesson, we were given functions that was like 3x squared plus 2x minus 7 over x or something like that, and we could divide this x into each of those terms. So it's 3x plus 2 minus 7x to the negative 1. And then I would use the power rule. But bad things happen if I add a plus 2 down there, and I can't factor it. So the way around this is by using the quotient rule. This is kind of a last-ditch effort. But this is the derivative of the bottom times the derivative of the top. So bottom times the derivative of the top, f prime, minus, always minus, the top times the derivative of the bottom, all over the bottom squared. The way that I have this memorized, and the way that I learned it when I was in school here, was low d high minus high d low, all over low squared. All right, so low d high minus high d low, all over low squared. If you say that to yourself a million times, that is the rule for the quotient rule, right? So low d high, right, derivative of f, minus high d low, the derivative of g, all over low squared, which is g squared. Okay, we'll get to there and use that rule when we have the opportunity. All right, so these first ones, just use the product rule to find the derivative of each. You could multiply this out for sure if you wanted to, like 3x to the fourth, whatever, blah, blah, blah. But there's really not a good reason to do that unless I forget the product rule or something, because I really need the product rule for things like part B down there. I can't do that derivative without knowing the product rule. So f prime, so I'm going to do the derivative of the first. I'm going to do it kind of a different order. The derivative of the first times the second, as is, plus the first times the derivative of the second. So still, I'm just going to do the derivative of 3x minus 4 as my power rule. That's all it is. and the derivative of x cubed plus 5 whenever I need it as the power rule. That's all I'm going to be doing on those. So once you get to this point, stop. Don't do anything else. There's no reason to do anything else because I have a correct derivative. As long as you are algebraically the same thing and numerically the same thing, there's no reason to simplify this or rewrite this unless I'm on a multiple choice. Okay, moving on. Part B here, so G prime, kind of my U and my V is the root T and sine of T. So if it helps you, rewrite this as T to the 1/2 sine of T. Eventually you'll probably do the derivative of the square root of something enough times that you'll just know the derivative is 1 over 2 root the derivative, or 2 root T or whatever. But if you're not there, that's completely fine. So I'm going to do the derivative of the first, which is 1/2 T to the negative 1/2 times the second, plus the first times the derivative of the second. And you can leave it like that and be done. All right. Use the quotient rule to find the derivative. So I have low d high minus high d low. So f prime. Low function is 2x plus 5. Low d high, so 4x, minus high, 2x squared minus 1, d low, all over low squared. All right, so low d high minus high d low all over low squared. All right, same idea here, right? The derivative g prime of a, this time I'm differentiating in terms of a, is low cosine of a, d high e to the a minus high e to the a. Remember the nice thing about e to the x is the derivative is e to the x. Low d high minus high d low, so negative sine, all over low squared. And that would be it. Just to kind of show you guys probably what is going to happen on a multiple choice is this will be written as such. More than likely, they will factor out that e to the a. They seem to like to do that with exponential functions. So that'll probably be factored out. Just know that that can happen. They will factor out common terms. So sometimes on the multiple choice, you're going to have to rewrite stuff in a way that you have the same answer, but it will match one of their multiple choice options. Okay. Find the derivative. Here I'm not telling you what you have to do. So, and that's how it's going to be on the AP test and how it's going to be on our test. We're not going to tell you that you have to use the quotient rule. We're not going to tell you you have to use the product rule. So it's up to you to decide what is best for you. In this case, we're going to kind of have to do a combination because big picture, I see u times v, right? It's product rule, big picture. But within the derivative of this, I'm going to have to use the quotient rule. So there's no big deal. I'm just going to take my time and make sure that I'm really intentional with everything that I'm writing and thinking through everything that I'm writing. So I have the derivative of the first, which will be low, so x squared plus 1, d high, 2x minus 1, minus high, x squared minus x minus 3, d low, all over low squared. Okay, this is where I see some students mess up, is they will do like the first part and then be done. They'll be like, man, that was a lot of work. But really all that we have done so far is u prime v. All right, so big picture, we still have to do plus uv prime. So u, I'm going to leave it alone. And v prime will be 2x plus 1. All right, so that was u prime v and u v prime. V prime is a little bit easier to do. All right. And really, that's about as hard as we are going to make these things. We're not going to make them super crazy hard or anything. We are going to have them such that you have to think about what you are doing, but they're not going to be wicked, wicked hard. This is probably about as hard as you're going to see. All right, so moving on. The derivative of secant. Well, Mr. Pike, that's not a product. Mr. Pike, that's not a quotient. Yes, it is. is 1 over cosine. So if I think of this as 1 over cosine, now I can do the quotient rule. And the derivative of secant is something that you will eventually, hopefully, just know. But let's see what it comes out to be. So low d high, so low d high minus high d low all over low squared. Okay. So now I have this front part, that's 0 times anything is 0. So I have sine over, I'm going to split up these cosines because I want you to see this. This is really 1 times sine. So if I rewrite this, it's like 1 over cosine times sine over cosine. We've seen these things before. 1 over cosine is secant. Sine over cosine is tangent. So the derivative of secant x is secant tangent. And if you are going into BC or any other higher calculuses, this is something that you should probably just memorize. Even in AB, it's going to be useful for you guys. These next two, secant and tangent, are pretty important moving forward. Okay, so the derivative of secant is secant tangent. Well, let's do tangent, which is sine over cosine. So the derivative of this would be low d high minus high d low, all over low squared. If I rewrite this, I have cosine squared plus sine squared. I think I've seen that before. Cosine squared. This is our Pythagorean identity from pre-cal. Cosine squared plus sine squared equals 1. So this, the whole thing, is just 1 over cosine squared. And 1 over cosine squared is secant squared. So the derivative of tangent is secant squared. That is the other one that I would highly suggest you guys just memorize it and you'll get used to it. Hopefully you'll have enough practice on these, seeing these so many times, you'll be like, oh, I should probably just know that. But the 4 that I really need you guys to know, other than sine and cosine, let's see, secant, don't do this again, use technology to help you. All right, duplicate, secant, duplicate. Usually I think of tangent first, and then that helps me come up with secant. And then I think of cotangent first. And that helps me come up with cosecant. Right, so star bonus available. Tangent is secant squared. That helps me remember that secant is secant tangent. This is really the only one that I have like 1,000% memorized. I've taught calculus a few times now, so I know this one a little bit better. And this one I know based off of that, because to me, tangent and secant are best friends. The derivative of tangent is secant squared. This is going to happen a lot. You will see this one quite often. But this one helps me remember that tangent and secant are friends. So when I do secant, secant and tangent are friends. And when I do cotangent, I just remember that secant and tangent are friends. So instead of secant, it's now cosecant. And I remembered if they are cos, that they are negative. Cosecant, same idea. Cotangent, cosecant are friends. It is negative, but they are two together. So those things are good to know. The bottom ones are not quite as important as the top ones, but you do need to know both with some ease, I would say. I don't know how else to say it other than you need to know. All right, now we're going to get into the next derivative of things. So the second derivative of these functions. So the second derivative is not super difficult. It's really just doing the derivative once and then do the derivative again to get the second derivative. So all I'm going to do is take my first derivative using my power rule. So 20x to the fourth minus 8x to the, holy cow, I keep doing that all day. All day I did that. 3 times 2 is 6. plus 5. All right, so there's my first derivative. And it is important to remember, too, that my original function represents the position. That is where I am. This one, the first derivative, represents the slopes of f. That is how fast I am. And then if I do another derivative, this would be the second derivative. It is notated with 2 prime markings. The second derivative here would be 80x to the third. So notice I'm still just going to take the derivative like I would, as if this was just f. So the derivative here, I'm still just going to use the power rule. There's nothing too crazy about it. Minus 12x, and then I lose my plus 5 since it's a constant. Now this is the slopes of f prime, which is the rate of change of the velocity. So if I have the rate of change of the velocity, that will represent my acceleration. Okay, so it's kind of important to notate these distinctions between the things. The slopes of f prime is my second derivative. The slopes of f is my first derivative, but that relates to my original function. And kind of how these relate is going to be important moving through calculus, very much so. And is one of the hardest things to really get straight in your mind as you go. But we will practice. All right, this next one I changed to make our lives a little bit easier. I want to do, that's right, I can use the white. Let's just do x squared. I think I did x in class, but we can do x squared. So f prime, low d high. So low d high would be 2x minus high d low, just 1, all over low squared. Now, an issue here is if I'm going to try to do the second derivative, I'm going to have to do low d high again. So probably I'm going to want to rewrite this stuff just to make it a little bit easier. So I have, let's see, 2x squared minus 8x. I'm just distributing these first two, and then I'll distribute the negative, which is just minus x squared. All of that over x squared minus 8x plus 16. So this would be x squared minus 8x over x squared minus 8x plus 16. All right, so now I can do my second derivative. So f double prime is low d high. So low is x squared minus 8x plus 16. So low d high would be 2x minus 8 minus high d low all over low squared. And for the second derivative, that is how I would leave it. Unless I absolutely have to simplify for a multiple choice part or something, don't do anything else. I don't want to have to take off algebra points when you were good at the calculus and you knew the calculus. So don't make me take the calculus points for algebra errors. Please, please. Okay, second derivative of this one. So h prime of t, let's just do our first derivative. I need to use the product rule since this is like a two functions multiplying. So the derivative of the first times the second plus the first times the derivative of the second. All right, so my guess is most of you will probably just go from here and treat this as two product rules, so you'll have 4 plus signs in your second derivative, and that's fine. Just note, too, that you could also factor out your e to the t. This is why they like to factor out e to the t. Right, and then I can treat this as two product rules. But either way you want to do it, it's completely fine. They're both going to be correct derivatives. So I'll do it the first way, and then I'll show you the second way. So h double prime of t is the derivative of the first, so e to the t times the second plus the first times the derivative of the second. Right, so that first part there was just the derivative of that first part up top. Plus, now I'm going to do the derivative of the e to the t cosine t. So the derivative of the first times the second plus the first times the derivative of the second would be negative sine of t. My e to the t sine of t will subtract out, and I have 2 e to the t cosine of t's. if you want to simplify that one. So the other way of doing this, remember you can always rewind. I'm going to erase a bunch of stuff, but you can rewind. Would be looking at it in this form. So h double prime of t, derivative of the first times the second, plus the first times the derivative of the second. And that would be it. So to me, the second version looks a little bit cleaner than the derivative of the first, but it does take some distributing and thinking about how that distributes to get down to the 2 e to the t cosine of t, if you needed to get there. But it's really, I'm just trying to show you guys, there's multiple options of working these things. You can do it however you see fit, as long as it's good math. Okay, here I'm trying to find, this is represented by the fourth derivative. That's what that's trying to tell you. Find the fourth derivative given the first derivative. So I'm going to use the first in order to get to the fourth. This fourth derivative, you could also see this represented by h of iv of x. That's how they will see the fourth derivative. Some textbooks, I feel like, would write 4, but once you get 4 prime markings, you really got to start counting. So most of the time I will only see kind of 3, and that's the norm, I feel like. And then from there you will go on to just notating with a number. So if I wanted to do the 20th derivative, you would probably just see h to the 20th prime of x is how you would see that notated. But there's not many times that we have to actually do that. So let's see. I have my first, so I'm going to go ahead and get my second, which is 28x to the third plus 6. Let's get the third, h triple prime of, let's see, 60 and 24 is 84, x squared, and then h to the iv. Let's do the different notation just so you see it again. What is that? 160 plus 8, 168, x to the first power, and there would be my fourth derivative. All right. Next, we are given the graph of f, and we have to find f prime and f double prime and graph them. So the important thing to note here is that I am given the graph of f, and what you will see me do on like multiple choice questions like this or free response, if they give me a graph and they tell me what the graph is, I will write on there huge what my graph represents, whether it's f prime, f double prime, whatever it is, just so I keep straight in my head what am I looking at. And in this case I'm looking at f. So for this one, f is again position. Y'all are going to get tired of me saying this. F prime, which I will do in red, f prime is the slopes of f. So if I'm thinking about the slopes of f, the slopes of the tangents, right there and right there are probably the easiest positions to think about my slopes. I'm changing direction, my slope is 0, so my derivative at those values will be 0. Because my slope is 0 at those positions. So there I will have derivative markings at 0. And then if I look at my function, it is decreasing. The slopes are going down the entire time. So I have to have negative outputs that wrap around so that I have to come back to that other 0 output. But this is negative slopes the entire way. And if you think about the slope there, it is not as steep as the slope here. So not as steep slope, and then this would probably be the biggest slope right there. And then it slows down and it goes back again towards a positive slope. On the outsides of these are all increasing but slowing down. This one is increasing and speeding up. So positive but slowing down, positive and speeding up. All right, so here would be my graph of f prime. F double prime is my slopes of f prime. So if I think about where f prime has a 0 slope, it's right at the bottom there, right when x equals 0. So I have, there is a part on my f double prime graph. And then if I think about this, this is decreasing, and then it goes increasing. So I have negative to positive slopes, so negative to positive slopes, something like this. And the green is my graph of f double prime. And if I think about these in terms of like a function, my original function is a cubic of some sort. So my derivative should be a quadratic of some sort, and my second derivative should be a linear function of some sort. 100%, they're not going to ask you to freehand sketch one of these on a free response question on your AP test, but also 100%, they are probably going to ask you, given the graph of f prime, or f double prime, which of the following could be a graph of f, or f prime? So they'll ask you the relationship. So maybe they gave you the graph in green, and they're saying which one of the graphs, they'll give you multiple choice, obviously, which one of the graphs represent f. So you'll have to pick the graph that has something like this. There are multiple representations. I mean, we could be up here and it'd be the same-ish graph. We could be down here and it'd be the same-ish graph. So just know they're more so looking about the representations and how you can think about the slopes and how they work together, rather than being able to like know the exact slope. I don't know this exact slope. We could calculate it, but I'm not going to worry about that right now. I just want you guys to be able to get general idea. Okay, moving on. Again, this is f. And if I want to graph f prime, let's see, I have a zero slope at the top here, so I have 0. I'm going increasing to decreasing, so I have a positive and negative slope. So there is f prime, something-ish like that. And now f prime is just a line. It's just a line with a slope of -2, or whatever it may be, right? Some negative number. So I'm just going to draw a straight line at some negative number, and that's about-ish what f double prime would be. If I ever asked you to graph freehand on a quiz or a test, I probably wouldn't. But if I did, I'm not going to be grading you guys on whether you have f double prime at -1 or -2 or -3. Unless I actually like give you functions, I don't expect you to like just know where exactly that is. Okay, last one. Again, this is f. So f prime, let's see, I have a 0 here, there, there, and there. And again, that's because I have 0 slopes. And then I go decreasing here, and then it goes increasing, and then it goes decreasing, and then it goes increasing. And this was increasing, even though it's going backwards. But, so, and if I think about this too, the original graph, that's just sine. So right now, the red one, I've graphed cosine. So the green one, I know is going to be negative sine, but let's graph it based on here. So a 0 slope, there, so a 0 slope, there, so a 0 slope, and shibba-bow, and shibba-bow. All right, so based on red, I am decreasing, increasing, decreasing, increasing, and there would be my super lovely, not very perfect graph of f prime and f double prime. All right, hopefully this video was useful for you guys. As always, let me know what questions you have, and I will talk to you all soon. Bye-bye.